Hello, and welcome to the Spec Shaman Podcast, the show that explores the world of building product manufacturers, architects, and engineers, sustainable design, and technology and trends. We engage in thought-provoking discussions with renowned experts, industry pioneers, and visionaries who are making a significant impact in the construction industry. Join us as we explore groundbreaking ideas, revolutionary concepts, and the latest advancements shaping the built environment. I hope you enjoyed this week's episode. Let's get started.
Welcome to the Spec Shaman Podcast. I'm your host, Megan Vipond, and today we're looking at something that often gets overlooked in design, but plays a massive role in performance, longevity, and even aesthetics: roof drainage. Joining me today is Craig Bach, the founder and president of RDCA, a company that's redefining commercial drainage. We'll discuss custom fabrications, specifications, materials, and why design professionals should be thinking about gutters earlier in the process. Greg, welcome to the podcast.
Thank you. Thank you very much.
Greg, can you share your origin story and how you went from corporate America to leading a company in commercial roof drainage?
Sure. Upon graduating from college back in the early 80s, I went to work for the largest, actually at the time, the largest aluminum company in the world, which also happened to have the largest metal technology facility in the world to teach its employees about metal fabrication and also do research. During my years there, it was during a time in the 80s and 90s when they were kind enough to provide me with hundreds of hours of training in how to manufacture with metal, particularly aluminum. And I was in a number of positions all over the country where I was very active dealing with aerospace companies, automotive companies, architectural, commercial, transportation, powders and pigments, and many other industries. Had to learn a lot about the product, saw a lot of facilities, saw an awful lot of aluminum facilities throughout the country over the years. And from that, really became comfortable with metal and had a great education in how to deal with customers in many industries over many years. Around 2002, I decided to try my hand at running a company, and that's where RDCA was created. We started as a very small manufacturer, making just a handful of residential downspout, selling some residential gutter coil and gutter machines, whereby I realized in pretty short order I needed to get into the commercial roof drainage business, that is non-residential area. And that's how RDCA evolved into what it is today, where we manufacture more than 8,000 SKUs. We offer more than 20 metal vendors in terms of colors, which includes over 400 colors. 17 metal thicknesses. We make product out of aluminum, steel, stainless steel, copper, and zinc. And we pride ourselves, which was an area I saw missing in the industry, on being a comprehensive consultant for the architect and the customer, helping them understand where they may want to do some redesign or rework on their what designs they have to ensure the gutter system drains properly and has enough capacity while holding up over the long term.
Fantastic. Now, how has the commercial drainage industry evolved since RDCA's early days?
Probably the thing I've noticed the most is for commercial drainage, aesthetics have become more and more important. So while the architect still wants, of course, a functional gutter system, that is one with enough capacity and enough structural integrity to hold up for the long term, they also want it to be cosmetically appealing. And that's where it's become even more important that they find a manufacturer that they can call out that can make everything they might need for any given project they are working on, both now and in the future. So they need to be able to have a manufacturer that, again, can do half round gutter, round downspout, box products, K-style products, custom style products in many, many different colors and metal thicknesses. That is something that wasn't is important years ago. Oftentimes, you just saw mainly box products.
So was there a niche that you saw in the market that made you want to focus exclusively on commercial applications?
There was. It's kind of similar or related to the previous question. It's very commonplace in our industry today. It was more common years ago, but it is still common that a manufacturer is not necessarily able to make everything an architect may want. They may not be able to do all of the colors that an architect may need over the long term, or they may not be able to do some of the thicker metals that you need for the bigger products, the bigger gutters, the bigger downspouts. They may not even potentially be able to make the bigger sizes, regardless of the metal thickness. Colors is often an issue. Again, to this end, that's where RDCA can be helpful with over 8,000 items, 20 metal vendors, and over 400 colors. Also, in this area, the typical manufacturer really can't be of much service or help to the architect as to whether or not the system they're calling out is big enough functionally to handle the water load. And again, they want to look for a qualified manufacturer who can do some analysis for the architect, saving them time to make sure the system's adequate.
Fantastic. It's really great to hear how RDCA's journey has shaped the way that you approach drainage in commercial applications. With all of that in mind, let's get into the educational and practical side of things. Why do you think drainage systems get treated like an afterthought in design? And what are some of the risks associated with that?
Probably it's a straightforward case for the most part of deadlines. Architects, like any profession, have deliverables they have for both I'll say for their boss or their customer. And when you look at a project, not always, but in many occasions, the drainage system relative to the total project is a low dollar volume item. So human nature is to not give it as much time because you don't think it's as important. They're up against the deadline. So what they do is, since it's not a particularly high dollar item, which doesn't mean it's not important, they go in and they use a specification they've used in prior applications, basically a cut and paste, which in some cases is certainly going to work. But in many, many cases, the specification used either does not adequately address the drainage needs of that building, or in some cases, we see where it's not even appropriate. In other words, they call out specifically certain products on a spec, and then you read further, and the details they give don't match what they're calling out. So primarily deadlines, I would say, but also it's sometimes people lose sight of its importance because it can be a low dollar item.
Yeah, absolutely. Could you walk us through some of the key due diligence steps an architect should take when selecting a gutter and downspout manufacturer?
First of all, I guess I would start with production capability. Can the architect needs to identify whoever they're calling out, can they make everything that they may need in the future, which in their half round is 5 through 12 inch half round gutter, round downspout is 3 through 12. You've got K-style up through 12 inch. You've got any and all sizes of box gutter and downspout. And then there's any custom requirements for some novel or unique shape they may need, as far primarily as a gutter would be concerned. Complementing that, do they offer all the colors that are needed? You really want to look to somebody who buys metal from many, many different vendors, because every vendor has a different color palette. And if the architect wants to have flexibility in their designs, they don't want to be constricted to one or two color palettes. They want to be able to choose from any vendor that's out there. They also want to make sure that the manufacturer is knowledgeable. They're not just an order taker. So they need to be able to call up their manufacturer and discuss with them the roof area and the slope and where it is, and send them drawings and have them review the drawings and double check that all of the geometry is correct for the mounting system, that they have enough structural integrity. And what about the cosmetics? Are the gutter support brackets going to match the gutter system? That's a key due diligence step that often is overlooked. On the gutter support bracket specifically, they really want to make sure that the gutter support brackets can be wrapped in the same metal as the gutter. And I can say with a high degree of confidence in our industry, more often than not, that is not the case. And it results in a pretty short order, the brackets not necessarily even matching the gutter that they're holding up on the building. All of this might be beneficial if they get assistance in maybe even designing the questions they want to ask, or qualifying a manufacturer, because this just touches the surface and there's many other things to consider. But I'll leave it there at this point.
Yes, absolutely. Now, in your answers, you've kind of touched on both form and function. What would be your advice for balancing those on projects where aesthetics are equally as important as performance?
Well, that goes really to two things that, if done correctly, it's almost going to be a foregone conclusion that it is done correctly. If you, in your specification, cover every possible option regarding any given project in terms of where it's located, what size of gutter is going to be needed, what thickness of metal is going to be needed, and it covers it for all shapes and sizes of gutter. So half round, through box, K-style, custom, etc. What happens is they refer to the specification, and based on the roof plan, it becomes almost impossible for them not to use the products that will functionally do the job. And then the spec itself for that given job calls out the shape to be used, and they're just referring then to the other information to pull out the correct size, if you will, and the correct metal thicknesses. So it starts with a comprehensive specification, but to complement that, and actually to save the architect time, there's kind of a win-win here. With the correct manufacturer relationship, if they have the relationship with the right manufacturer, the manufacturer will gladly check all of that to make sure the function is acceptable, and they more or less just need to worry about the form or the look of the building or the gutter and the downspout system. Your provider should be willing to do that. If they're going to be in the spec, they ought to be willing to spend the time to do that, and I would say more often than not that would be the case.
Now, what role does recycled content play in roof drainage component manufacturing?
This is an easy one. Gutters are made in the commercial world, not including residential. Gutters are going to be made of either steel, aluminum, stainless steel, copper, or zinc. And it happens that all of those metals are very recyclable. So what that means is if something's damaged, or you simply want to replace it, or let's say the building's at the end of its life cycle, all of that can be recycled at your local scrap dealer, or if it's a large amount, you could actually go to a scrap processing facility, and it all can be sold at market value and recycled. So when you're designing your system, you're fortunate in that you don't really need to consider the recycling part of the equation, because again, no matter what you choose, it's going to be readily recyclable.
That is fantastic with the recycled content there. And in terms of material selection, you mentioned a few. How should climate and environment influence the choice?
So let's take the environment first. What I mean by what I would say when I think of environment in this regard gutters and downspouts, it really speaks to, is the building you're designing in a heavy industrial area? And if it is, are there chemicals, airborne chemicals, not necessarily, by the way, that are hazardous, which would be a whole separate conversation, but there can be airborne chemicals in the air that are not harmful to people, but they might be harmful in terms of corrosion for the metal being used. And so you would want to check to make sure the metal from that perspective is not going to have an issue relative to corrosion. In terms of climate, you really want to give some thought to, is it going to be in a salt air environment near the ocean, or is it going to be in a tropical area? Those are going to lend themselves to corrosion, and certainly you'd in those cases lean more towards a marine grade stainless or an aluminum product. However, contrary to that, generally speaking, with exceptions, steel can be quite a bit stronger. So you end up having to compromise a little bit in that area and probably go with a more thicker aluminum to offset its lower strength, but still maintain your corrosion resistance. So the other thing you want to think about is regarding snow loads, ice loads. You've got to make sure it has enough structural integrity. So that can lead, for example, things up in the Northeast corridor or up in the Midwest. You would want to tend in your specification to the heavier metal that you call out, as opposed to, say, if you're down, let's say, in the Southeast, while you still have to consider hurricanes, you don't have to consider snow loads as much, which then could affect your thickness decision.
And how important is it for manufacturers to offer a range of color options? And do coating types factor in?
So let's deal with the color options first off. It's really, really critical that the architect make sure that the manufacturer has access to many, many different metal vendors, each offering their own color palette. It's common for a vendor to offer, say, 35 different colors, and every one of them has a different color selection to choose from. And the architect needs to have the flexibility that when they're doing their plans for their structure, they can be calling out any metal vendor they want for their roof or their wall panels or their edge metal, whatever the case may be, and be assured that whoever they've got in the spec for the gutter and the downspout has access to those colors. So they're going to create, or can create, quite a bit of confusion if that isn't dealt with up front in their specification in terms who they specify. Secondly, regarding coatings, there's really three primary types of coatings in our industry. Certainly the most common would be, officially it's a PDVF coating. It's commonly called Kynar, which is a trade name. That is easily the most common coating system in our industry. It usually almost always carries a 20-year paint warranty, and it's offered by dozens of different metal suppliers in hundreds of colors. It also happens to be the most expensive, but again, it's extremely durable, and it's very easy to work with if you're the manufacturer. Right behind that, though, you could go with an SMP system, which is a little cheaper, which is obviously a benefit. It still offers a nice paint warranty. 30 to 40 years would be common. However, you're going to find that fewer vendors offer it, and it has a more limited color selection. In fact, in the SMP world, with the vendors that do offer it, many of their colors even match. So color matching becomes less of an obstacle in terms of color. However, it's only offered, or almost only offered, in thinner metals, typically 26 and 29 gauge steel. So immediately, if you're going with a project that requires heavier metal for integrity or aluminum, you probably wouldn't want to use SMP. And the last one to give some thought to, but is frankly not often used in a specification in terms of architectural applications, is pre-baked enamel, which is what's used on almost all single-family homes. It's basically a baked on enamel paint that is sprayed on. It's a very thin coating. It does cover the metal, but it carries no paint warranty of any kind. It's by far the cheapest option. It's not even close. But again, it is going to fade. It is going to chalk. And usually in commercial applications, the architect's not going to use that unless budget becomes an extreme issue. You want to make sure, I guess the last thing is you would want to make sure that your provider, your manufacturer, does offer ideally all three systems. So the architect has maximum flexibility.
Yeah, absolutely. So we've touched on color and coatings. What about shapes and profiles? What are the advantages of having a multitude of profile capabilities?
So it kind of goes along with the rest of our discussion, is that as a higher importance is given to buildings to have a more aesthetically pleasing look, it's become more and more important that the manufacturer that's chosen can make all the shapes in sizes. A good example, it's one of many I could give, but a good example in our industry is you may talk to a manufacturer that says, yeah, I can make a half round gutter. But then when you start digging deeper, what sizes can you make? And they may tell you, well, we can make a 5-inch, a 6-inch, or an 8-inch. But then once you get into something that's bigger than that, they really can't make it or don't want to make it. Or if they make it, it's so expensive, no one's going to want to buy it. And your manufacturer needs to be able to make all the profiles, both the shapes and the profiles. So that'd be half-round gutter, K-style gutter, any box-shaped gutter you want, which come in almost an infinite number of shapes. They need to be able to make all of those in any size, from very small to very large, and then offer them in many colors, as we've discussed, so that the end product, the product that's finally used, can handle the water flow and has the structural integrity needed for the long term for the building. Again, size being sometimes a big constraining factor for manufacturers, as well as they may be able to make a profile, but they can't make it in the thickness you need.
So what about downspouts? What's the value of having comprehensive sizes and style offerings for those as well?
Well, that's something that's often overlooked, but really what determines complementing aesthetics, you want to be able to buy downspouts in different sizes and have flexibility. So an example I can give is if you're doing an aesthetically pleasing building, and even if you want just a straightforward box downspout, if it's got to be aesthetically pleasing, you're probably going to want those placed in discrete locations on the building so they're not that noticeable. And that's probably going to mean that from a water flow perspective, they're not in the ideal position. Or from a water flow perspective, you want fewer of them than you really might think you need. If your manufacturer can make an extremely large one, let's just say, for example, an 11 by an 11 downspout, which would be pretty extreme, you then have the opportunity, if placed in the right locations, to vary the size of your downspouts, which then allows you to use fewer of them and change where they're located, so they offset the fact that from a functional perspective, they may not be in the ideal location. This is not going to be as important if you're just looking for function, say a distribution warehouse or something of that nature, but something that has aesthetic requirements, this can become very important.
Now, obviously, this all has to be connected to the building somehow. Why do gutter support brackets often get overlooked in the design phase?
Well, I'll say first off, it may even be the case that they're not overlooked. It may just be a lack of knowledge. It really is not realistic to think any architect or really anyone is going to have a knowledge of everything that's available in the marketplace. So generally, people go with what they know. And there are gutter support brackets that were developed many years ago that are still available that are commonplace in the industry that end up getting specified that in many cases their structural integrity or the load they can carry relative to the end use is very questionable, or we see it quite often where a specification is called out and what's called out for the gutter support bracket won't even fit the gutter being called out or the gutter you should be using. So it's a total mismatch, and you have to go back to square one, and you end up either having the GC or the roofer frankly use something that isn't specified, or they go back to the architect and have to figure it out, which can delay the project for quite some time because obviously the manufacturer can't make it if they don't know what they want the customer to have them make. The other reason goes back to what I've said in an earlier question is it's generally considered a smaller dollar item on the building. And I guess I would just talk it up to human nature. That is something then that usually doesn't quite get as much attention when in fact it should. All of this, frankly, can be addressed if specifications are written comprehensive and thoroughly.
And what makes for a high quality, long lasting bracket?
So there's really probably three areas to consider. There's the structural, the cosmetic, and the installation. Structurally, you've got to make sure that the material being used is the correct material with the correct thickness, correct width, correct dimensions, and is structurally strong enough to withstand the heavy loads repeatedly it's going to undergo either from ice or snow or even hurricane force winds. It's got to be able to withstand all of that. And that's where, again, your manufacturer can be very helpful in advising what can do that. You want to make sure it's not going to corrode is another thing you want to think about. And so it not only needs to have the structural integrity, it needs to be materials that won't corrode, or else long-term it will not be structurally sound. Cosmetically, you really want something, ideally, I think, that's going to look as good as the gutter does over the life of the product, which can be 30 years or even more. And that speaks to something mentioned earlier, where you really, if it's a painted product, want to be thinking about using a gutter support bracket that is not post-painted, but that is covered with the same material used for the gutter, specifying the same material and requires the same paint warranty so that 20 years down the road, the finish on the gutter and the finish on the bracket are identical because they use the same material. Now, point of clarification here, this is simply the covering of what's the structure is of the bracket, the structure being what's carrying the weight. We're talking about the covering in terms of cosmetic appeal long term. And then installation. All of this is for naught if the installer does not install it correctly. They can always ask for instructions. They should always come with drawings so they know how to install it. And then, of course, the correct quantity must use, the correct spacing must be used. If that isn't done, you can have the best bracket in the world, and if you don't use enough of them or install it incorrectly, it's going to lead to problems.
And can you explain how bracket, hanger selection, and attachment details can contribute to the structural integrity of the roof drainage system?
In terms of the attachment, if the manufacturer doesn't have the knowledge to work with the installer to make sure the pieces of the gutter support bracket will correctly fit the geometry and the materials used on the building to where it's going to be fastened, it's going to lead to the fact that the gutter is either going to not be sloped correctly. You could have sagging gutter in certain places. A common occurrence would be actually the joints where you fasten the various pieces of gutter in downspout, where you're going to have leaking, because once the gutter system starts moving around, it's going to start breaking the seals or the connections, even done correctly. So you obviously need it to be held in place for the long term during all of the weather situations it's going to experience. You also can run into corrosion. If you don't use the correct materials, it can corrode, which eventually is going to lead to either leaking or failure. And frankly, the bracket system is kind of like the foundation of a building. If the bracket system is not done correctly, you can actually have over-engineered, over-designed gutter that's too big and it's really overkill, and yet the whole system can be a failure just because it's not fastened to the building correctly. It also can cause inadequate water flow related to all the above. If the gutter support brackets are not done correctly and installed correctly, it can start to cause pooling in the gutter system, which then can lead to snow and ice buildup, or it can lead potentially to water backing up into your building structure.
So it sounds like proper specifications are really important here. How can doing that up front reduce waste during installation?
Okay, so it's a good point. Doing a quality job with the brackets and having the correct attachment details, which is really comes from the manufacturer, can lead to a reduction in waste because you may be able to go with a bigger downspout to lower your cost, or you may be able to change the size of your gutter on different parts of your building, so which would save money. So for example, if you have multiple sections of a building and you do the water flow analysis, and one section, let's say, takes a 10-inch box gutter, if you have the correct manufacturer who can do the correct analysis for you, he may look at it and say, sure, you need a 10-inch gutter there, but going over to this section, we can just put a 5-inch gutter on this one and dramatically reduce your cost. So you only use what you need instead of having to kind of with a one-size-fits-all. And so you can either maybe, I'll say, shrink the size of what you're using, or go with thinner metals, which can be a significant saving in some areas on the building for the gutter and downspout, whereas in other areas you may have to go with bigger and thicker. But the result is it's all customized for what you need, and you're either buying fewer parts or you're buying less expensive parts, which in turn leads to a lower total cost. Although some components may be more expensive, the total cost ends up being less. And another word about gutter support brackets, if you get the most appropriate bracket, oftentimes you can use fewer of them. They might be more expensive on a unit basis, but by using fewer of them, you cut down on installation time and you cut down on your material cost.
What factors most influence the long-term durability of gutters and downspouts?
The short answer is, are all of the specifications for that job sufficient in all aspects? Now, what I mean by that is, from a drainage perspective, is there adequate capacity to drain all of the water off of and away from the roof and the building under the most extreme situations? And that's relative to capacity and sizing. And from that, then you have to make sure, do you have structurally what you need to have? Is it thick enough metal? Is it, obviously, you've already looked at, are the components, downspouts, the gutter, and the other components, are they big enough? You need to look at regarding these two things very specifically, is the support of the gutter satisfactory? So much attention needs to be given to the gutter support brackets, making sure they fit the roof line correctly when installed, obviously that they're installed correctly following the instructions that should be provided by the fabricator, and are enough of them used. The other things that affect long-term durability is the location of the building, both from a weather climate standpoint, as well as is it exposed to any airborne chemicals. They're not necessarily hazardous, but they may be a chemical that does not react well with a given metal, and that needs to be considered with industrial type facilities. And finally, you might want to give consideration for long-term durability, even though it's not usually thought of in this way. Do you need to get a paint warranty? Because a paint warranty, the paint itself can be a great impediment to corrosion. So if the paint holds up long-term, you may avoid long-term corrosion. The last thing is installation practices. If you've got everything above is perfect, if you've got everything sound structurally, is sized well, if it's not installed correctly, it can all be for naught. Because you end up with leaking, you end up with water that's not being drained correctly, so it backs up in the system, and these items can lead to failure.
So something that always needs to be thought about with a lot of components in building design is codes and standards. What do the ANSI, SPRI, GT1, 2, and 3 standards cover, and why do they matter?
Okay, GT1, GT2, and GT3, again, they were developed by ANSI SPRI, an organization, and they are all three a specific detailed methodology on how to test box-style gutter. And I want to emphasize box-style. These tests are applicable to box-style gutters only, and are not applicable to K-style, half-round, or other shapes. Now, going back to the methodology, what they do is they are a test method to apply measured pressure on a downward direction or a measured weight in a downward vertical direction, pressure on an upward vertical direction, and pressures on a horizontal direction. And these pressures are to simulate, or weights are to simulate, on the downward direction, snow and ice loading. On the horizontal and the upward directions, they're more concerned about loading the gutter is undergoing relative to strong winds, specifically hurricanes. Once you test the gutter to failure, you have a reading in terms of the amount of pressure or the amount of weight, and you can cross-reference this to what that would mean relative to wind, or again, weight is obviously weight. And from that, you know at what point are they going to fail in terms of either wind speed or weight. And that actually can be cross-referenced in the International Building Code, Chapter 16. Guidelines are given as to, for the type of building and the location of a building, which are key factors on what the suggested minimum failure point should be. So it's a great guide for box style gutter. You might be able to use it to infer certain things on other shapes, but it's something that was developed in recent years to try and make structures safer.
And what are the most common compliance or code issues regarding gutter mounting materials or sizing?
Well, compliance can be a bit of a gray area in the commercial gutter and downspout area. In many cases, there are not specific codes for the gutter in many areas. And so you get into a judgment issue, which can sound a little scary, but for years it's worked fine. Really, what you have to look at is you can use the International Building Code guidelines if you want to be a guide, but again, they're not specific for anything but box style. And you need to look at things from enlist the help of a manufacturer who's qualified, and they can help you with exactly what load the brackets are needed for a certain gutter system, and if their brackets will do that. Also, that gets into spacing of them, of course, as well, which spacing can have a dramatic effect on how big a load the bracket will actually handle. It really becomes engineering judgment on the part of the architect, and we would say with a qualified manufacturer to ensure it's a safe system. But in terms of violating codes, while there are certain codes out there, more often than not, it's a judgment issue. I would also tell you from a practical level, it's not realistic to think that every single building that's constructed in North America can be inspected, and that's just not realistic. So you do really have to rely on the manufacturer and the architect, and the installer, I might add.
Now let's talk about design challenges and real-world solutions. How do you see the needs differing between high-profile, style-driven, and purely functional facilities?
It's a case of you still need to maintain correct functionality. Again, that means from both a water flow standpoint as well as structural integrity. Typically, a aesthetically pleasing system may not be a box style, and oftentimes, therefore, it doesn't drain as much water. It may not be quite as effective. So that's where the correct analysis needs to be done. A knowledgeable fabricator can do this to make sure using the profiles you want, so it's still the style of building you want, things are big enough, in the case of downspouts, big enough and spaced correctly or located correctly to still do the job for you functionally. That's a lot easier to do when you're just dealing with box shapes of gutter and downspout on, let's just pretend, say, a distribution center or a warehouse. Not so much on an aesthetically pleasing building with different roof angles and shapes and sizes.
And what role does placement play in both aesthetics and performance?
So again, aesthetics is probably not a major factor on a building that's just for functional purposes. And so you're really just worried primarily with performance, which gets into just spacing things in a more uniform manner, using primarily the same sizes of everything. Once you get into something that needs to be aesthetically pleasing, you're going to be looking at perhaps shapes of gutters and shapes of downspouts that may not drain the water as well. All of this can be analyzed and verified, or assistance of a fabricator to help the architect determine what their capabilities are. But that's going to affect, from an aesthetic standpoint, where do you want to put them? You probably don't want them in an area that's real conspicuous as far as downspout goes, so you may want to move them, let's say, out of the front of a building. That is going to require, more often than not, that you change both the size of the gutter and the size of the downspout so you still have adequate water flow. It may even have an effect on how the spacing of your brackets go, may or may not. Again, you really would benefit by verifying this or consulting with your fabricator to make sure you have accounted for good functionality. And you want to make sure, of course, like we talked about before, that the fabricator can make all the sizes and metal thicknesses you need.
Now, we can hope it doesn't come to this, but how can poor drainage design compromise a building's safety or even the structural performance?
If you don't have correct drainage or correct flow, and probably most people know this, it's just not often thought about, is you can have interior water damage from ice and snow backing up. Even water can back up if you're in a extreme storm situation and it cannot handle the volume of water. It can back up underneath the roof, which obviously can damage the interior roofing. Or what some people don't think about is the water can be running down inside the wall and you not even know it. So it's just slowly causing damage, and you probably would have a mold issue. On a lesser issue, it causes leaks in the connections. If you have leaks in the connections, while that may not be an issue in the short term, again, it can cause drainage problems, which can lead to backup, causing interior damage, or with enough leaking, let's say at gutter connections, you can over a period of time have water pooling at the foundation of a building, and that over time is likely going to cause either leaking into the building or potentially a structural problem. So yeah, it's generally not it's something that happens immediately, but over time, if you don't have the right design, you are going to run into some structural issues.
So what strategies then can architects use to ensure all drainage components work seamlessly together?
Again, it starts with the specification. This is where it's better if a specification is used that covers all shapes and sizes of buildings, roof slopes, all shapes and sizes of buildings and gutters and roof slopes in any area of the country, including, the far north, Canada, the Caribbean. It covers all possibilities. That becomes really the reference point that tells the GC and the roofer what they've got to use. And it's not just necessarily a cut and paste of one specification. I want to actually, as an aside, mention, and because I hadn't thought about it earlier, is that there is a great reference tool out there that isn't necessarily set in stone, but an organization called SMACNA offers some great guidelines in terms of making sure gutters function adequately. The other thing is, though, in addition to the specification, is, again, make sure you specify a fabricator that can do everything you're going to need over the long term. Because if they can't, even if the specification is written correctly and comprehensively, the temptation is going to be to use something different than what's called out because it's not readily available, and then the specification is for naught.
Can you share examples of when custom fabrication solved an unusual installation challenge?
Yeah, I can. Over the years, there's been many of them, but we actually worked on a job. It probably is a few years ago now, but it was for a major northeastern city in the U.S., and they had a facility of an industrial type located underground. Underneath actually what was a very, very large public park next to a large river. And they had fixed structural problems. Over years, the underground facility had developed structural problems, significant structural problems. They had been rectified, but they could not seem to rectify getting drainage issues. So they had drainage systems set up for the water to drain from above down around the system and also through the facility. they had things designed, but it basically had become dilapidated and they needed to redo it. So we came in there and it took some time, but actually what ended up getting designed was a 22-inch half-round gutter system, which 22-inch half-round's unheard of. But we were unable to make it out of marine-grade stainless, and it used a combination of designs of support brackets and gutter support systems that were compromised not only of structural bar, but also actually utilized chains, and came up with a whole system to drain the water safely out of the facility. That's really one that comes to mind because it really wasn't even for a roof, if you will. It was for an underground facility, but with our knowledge, we were able to design the system for them.
Yeah, absolutely. That definitely sounds like an unusual installation challenge. Now, looking into the future a little bit, what considerations should be made for end-of-life recyclability of the metals used in roof drainage systems?
Well, again, fortunately, it's an easy one in our case. So the metals you're going to pick from, steel, aluminum, stainless steel, copper, or zinc, all of them are readily recyclable. So at the end of life, or if a repair is needed, or any other situation, whatever is taken off the building can be recycled at a local recycling facility, just like you would recycle your aluminum beverage cans. Or if it's a large project, you'd probably want to truck it off to, there's actually facilities that process the scrap itself. You don't have to go through a local broker, and they can do it. But fortunately, when you're designing a commercial gutter and downspout system, since all the metals you're picking from would all be recyclable, you really don't need to consider that when you're making decisions on the front end.
What are some of the biggest misconceptions that architects may have when specifying drainage components?
Probably, it ties into our whole discussion, is that functional optimization of the gutter system, particularly when it's a project where aesthetics are more important, is not given the time and attention it should receive, which then can lead down the road to drainage problems or aesthetic problems. So the very thing that's important to them becomes an issue because the products that are used are substandard for what the application requires. So that again can be combated by an optimal specification that's very comprehensive, and actually getting the manufacturer that you specify to do some of the work for you if you're the architect, which is a good thing, and making sure that while it meets the aesthetics, it also meets the performance requirements and structural requirements.
And in your experience, why is it so critical for architects to work with a qualified gutter and downspout manufacturer?
I guess I'll try and answer this one a little bit from the architect's perspective. So the architect, like everybody, he's got responsibilities. He's also got a personal life, and he wants to go home at night. And typically you're getting near the end of the project, perhaps, or the design part of the project, if you will, when you're getting into gutters and designs. And if the architect will align itself or herself with the appropriate manufacturer that can cover all applications, you can have very justifiably, as the architect, have your manufacturer do a lot of the work. Because if you say, okay, I'll put you in the spec, or I'm going to put you in the spec, but I need you to verify that I've got enough capacity here, that everything is structurally sound, that things are in the right location, with the metals I'm calling out work, do I have enough brackets? Are the connections, do I have the connection points done correctly, or are they in the right place? You can have, and then you've got the specification that's comprehensive and thorough. You can actually, as the architect, essentially do almost no work other than calling out cosmetically what you want to be used. So that would be the shape you want of the downspout in the gutter and possibly, let's say, collector heads or other items. But then you let the spec that you are using in all your projects, you're using the spec that will cover any potential project, and you're going to delegate checking everything to the manufacturer. The manufacturer is going to be willing to do this because they don't have a guarantee, but they've got a high degree of assurance that they're going to be the favored supplier for that project. And that would make it worthwhile for them to do the work.
And what resources are available for architects when designing these systems?
Well, to begin with the manufacturer, as we've just discussed, that would probably be where I would go because it would be very efficient for the architect, take very little time. It's usually going to be a phone call or exchange of emails. There really are no comprehensive resources in the industry other than that right manufacturer. I referred earlier to what's called the SMACNA organization. They do offer in their manual some guidelines, and they're very good guidelines that can be helpful, but they certainly aren't comprehensive enough to do a specification or answer every question. So I'm gonna tell you, you really need to have, unless you want to pay a consultant, which I'm sure the architect as a rule would not want to do, you really need to find and use the right manufacturer that can cover all commercial situations.
Can you share a project where proper specifications maybe prevented a serious performance failure?
So I'm not sure about a specific one. I can probably give you, though, situations that we see on a routine basis, meaning weekly basis, that we're preventing the failure before it even occurs. So when we have someone call us, a customer, obviously the installer, and they are telling you what they need, it is very, very common that all of the components and accessories have not been thought about, or if we learn enough about the project, again, they're going off a specification from an architect that maybe wasn't appropriate for the project at hand. So they're calling out too small a gutter or the metal's too thin. Those would be good examples. Or we have seen many situations where they're not using gutter support brackets that are strong enough. And we've seen, conversely, actually, we've seen some situations where they could actually, it wouldn't lead to failure, but we save money because we tell them you can actually use fewer brackets. So we're engaged on the front end to try and mitigate serious performance failure. And it is very common for us to suggest a thicker metal for a gutter than we're being requested, or a bigger profile than requested, or we're even suggesting they change from aluminum to steel or steel to aluminum. We've had situations where we've said you're going to have corrosion issues when they didn't think about it. And that, again, that's a weekly occurrence if you're in customer service where I work.
And looking back, what's the one piece of advice that you'd give a designer specifying commercial roof drainage?
Well, I guess that what I would say is don't just let time constraints dictate that you rush through it. And to avoid time constraints, because again, you've probably got a very full workload, is to get with the appropriate party to develop a specification that's highly comprehensive for all applications that might be out there in construction land, if you will, and lean on a manufacturer that is very knowledgeable and capable, and let them do a little more to earn their keep, if you will, and have them do some of the work for you. But again, since the architect's responsible, what is critical here is up front to find the right manufacturer and have a comprehensive, correct specification. Once that's done, they can avoid shortcutting or not giving enough attention to the design part of the gutter and downspout system, because essentially they're just looking at the cosmetic side of it. I guess that would be the one piece of advice I would give an architect.
Fantastic, Greg. Thank you so much for taking the time today to share your experiences and wisdom with us. This has really been a great discussion on why roof drainage design deserves more attention. We appreciate you joining us on the Spec Shaman podcast as we continue exploring the details that make great architecture possible.
Thank you for listening to the Spec Shaman podcast. If you enjoyed today's episode, please subscribe to our show and leave us a review. A huge thank you to our guests who made this show possible. Building product manufacturers who want to increase their specification opportunities, please visit specshaman.com or ronblank.com. Thanks all for this episode, folks. See you next time.